Good morning, students. In this class, we are going to discuss about polynomials. The first unit itself, we already discussed about the polynomials. So, what is the difference between Unit 1 polynomial and Unit 2 polynomials is, in Unit 1 polynomial, the polynomial equation that representation using the arrays. But in Unit 2, the polynomials representation using linked list. That's the difference. Okay. Now, what is polynomial? All of you know about the polynomial equation. The polynomial equation has coefficients and exponents. A polynomial is an expression that contains more than two terms. A term is made up of coefficient and exponent. It's a polynomial equation. This is one of the example of polynomial equation. We can denote the polynomial equation P of x. So the equation is P of x equal to 4x cube plus 6x squared plus 7x plus 9. Here there are four terms are there. The first term is 4x cube, second term 6x squared, third term 7x, then fourth one plus 9. So this is the polynomial equation. When you consider this equation, what is coefficient and what is exponent? When you take the first term, 4x power 3, the coefficient is 4, exponent is 3, x power 3. When you consider the second term, coefficient 6, exponent 2, x square, x power 2, that's the exponent, 2 is the exponent. Then when you consider the third term, 7x, that is equal to 7x power 1. So coefficient is 7, exponent is x power 1. 1 is a exponent. Then when you consider the last term, 9 plus 9, only 9. But actually 9x power 0. We know x power 0 equal to 1. A power 0 equal to 1. So 9 into 1, 9. So no need to specify x power 0. So the last term only contains 9. But the coefficient is 9, exponent is x power 0. So exponent is 0. Okay, you consider this polynomial equation. Then in second unit, the polynomial representation using linked list. The important application of linked list is to represent the polynomial and their manipulations. The main advantage of linked list for polynomial representation is that it can accommodate a number of polynomials of growing size so that combined size does not exceed the total memory available. Then the polynomial has two fields. That's very important. The polynomial, each and every polynomial has two fields, exponent and coefficient. So the structure of node, all of you know in the linked list, you have to use the nodes. What is linked list? In the linked list, the nodes are connected together. Each and every nodes that link with another node. So each and every node has two parts. One is data part and link part. Data part, the node consists the data item. The link part has the address of the next node. Link with the next node. There is a node structure of one of the linked list. So the linked list number of nodes are linearly connected. Here, when you represent the polynomial, the structure of a node, the terms are stretch polynomial. You know the structure. Stretch polynomial. Polynomial is a structure name. It has three fields because each and every polynomial has exponent and coefficient. So three fields. The first field coefficient, second field exponent, then third field the link, because in the linked list the link field is must. Then only one node can link with another node. Each and every node has the link field that holds the address of the next node. But when you consider the polynomial in array, there are only the structure of the polynomial is it has only two fields, coefficient and exponent. But when you consider the polynomial using the linked list, the structure of the polynomial has three fields. So this is the structure of the polynomial. Struct polynomial, three fields, int coefficient, int exponent, then struct polynomial star next. Next that represents the link that specify the address of the next node. So when you consider the polynomial representation using the linked list, the node of a polynomial is it has three fields, coefficient, exponent and link. For example, you consider this equation 3x squared plus 5x plus 7. Here there are three terms are there. So three terms, so there are three nodes are there. The first node that represents the first term of the equation. The second node that represents the second term of this equation. The third term that represents the third node. The third node that represents the third term of the polynomial equation. So 3x squared plus 5x plus 7. There are three terms are there. So there are three nodes are there. Each and every node that has three fields. The first field to represent the coefficient, second field to represent the exponent, then third field link field that represent the address of the next node. So you consider this example. In this example, the first term 3x squared. So the first node, first coefficient 3, x power 2, exponent 2. So 3, 2, then link, which specify the address of the next node. Then second node, second term 5x. 5x means 5x power 1. So the second node, the coefficient is 5, exponent is 1, then link node, link part. That's the address of the next node. Then when you consider the third term, the third node 7. Okay, the third term is 7. So 7 x power 0, a power 0 equal to 1. So no need to specify. But x power 0, the exponent is 0. So we can represent the third term, the third node, coefficient is 7, exponent is 0, then link part is null. Because in the linked list, the last node of the link part is specify the null value. So we can specify the last node link part is null. So this is the example to represent the polynomial equation using the linked list. Then adding two polynomials. How we can add two polynomial equation? For adding two polynomials using array is straightforward method. Okay, we already discussed in the first unit using the addition of two polynomials using arrays. Here The adding of two polynomials using linked list require comparing the exponents. Because if the exponents are same only, the coefficients are added. For terms with different exponents, the complete term is simply added to the result, thereby making it a part of addition result. Because the exponents are same only, we can add the coefficient. We are going to add the two polynomial equation. So these two polynomial equation has some terms. Each term has coefficient and exponent. So our aim is we have to add these two equations. If the exponents are same only, we can add the coefficients. If the exponents are different, the complete term is simply added to the result and thereby making it a part of addition result. We consider this example, the following example. We consider this example adding two polynomial equation. We take two equations. First equation 5x power 2 plus 4x plus 2. Second equation 5x plus 5. Only two terms in the second equation. So when we add these two equations 1 plus 2, we can get the resultant equation, that is 5x squared, because the first equation has 5x squared, x power 2 term. But in the second equation, there is no x power 2 terms. So only you can write 5x squared plus the second term, the first equation and the second equation 4x, 5x. X power 1, x power 1. The exponent is same. So we can add 4x plus 5x, that is equal to 9x. So the resultant equation 5x squared plus 9x plus 2 plus 5. 2 plus 2 x power 0, 5 x power 0. So we can add the last term. So 2 plus 5, that is 7. So when we add these two polynomial equation, we can get the resultant equation is 5x squared plus 9x plus 7. So this will be represented using the linked list. Here you listen the first list 1. The first list 1, we can represent the linked list for the first polynomial equation. So you listen the first polynomial equation 5x squared plus 4x plus 2. So each and every node has two parts. First part coefficient, second part exponent, third part link part, address of next node. So when you consider the first equation, there are three terms. So we need three nodes. The first node to represent the first term, second node to represent the second term, third node to represent the third term. So first term coefficient 5, exponent 2, then link parts. Then second term coefficient 4, exponent 1, then link part. Then 2. The third node, the coefficient is 2, x power 0, so exponent is 0. Then last node in the link list, always the link part is represented by the null value, so null. Then plus list 2. List 2, that is it consists the second equation. So second equation 5x plus 5. It has only two fields. So there are only two nodes. So two nodes, each node has three parts. So first part of the first node, the coefficient is 5, exponent is x power 1. So 1, then link part represent the next node. Then second term of the second equation, we can specify in the second node of the linked list. So second node, first part, coefficient 5, x power 0, so exponent 0. Then the last node always has the link part that is equal to null value, so null. So when we add these two equations, 5x squared plus 9x plus 7. So the resultant list has, there are three terms, so three nodes. The first node of the first part, coefficient 5, x power 2, so exponent. Then third part, link part, that specify the address of the next node. Then plus 9x, because 4x plus 5x, the exponent are same, so we can add these two, 4x plus 5x, 9x. So coefficient is 9, x power 1, so exponent is 1. Then third part, link part in the resultant equation. So link part specify the next node, third node. So third node, so resultant equation, third term is 7. So 7 x power 0. So coefficient 7, x power 0. X power 0, 1. So no need to specify x power 0, but the exponent is 0. So 7, 0. Then last node, let's specify the null value. So this is the example of adding two polynomial equation using linked list representation of polynomial equation for addition. Okay, two equation, resultant equation. So linked list we can use the nodes. The nodes are connected together. So each term we can specify as a one of the node. So first equation, three terms, three nodes. Second equation, only two terms, so only two nodes. So resultant equation, we can add these two equation, we can get the resultant equation. That's in the linked representation. Okay. Thank you, students.